Hello, welcome to the AWS Certified Cloud Practitioner Exam Training session number 7. Here we are trying to get to the training within 2 weeks, and I've condensed the whole preparation materials, and I'm going through just the materials that you need to pass the exam. Um, so let's get started. A little bit about myself. My name is Anand Thirumanur. I'm a Google certified professional cloud architect. I have over 3+ experience of AWS and with GCP. And I recently completed the AWS Cloud Practitioner Certification. So for the AWS Certified Cloud Practitioner, we have been covering the cloud concepts of security and compliance. And today is the penultimate session for technology. And in the last two sessions, we'll cover session number 8 and 9. We'll cover billing and pricing, and then we'll take up sample questions. So let's focus on technology, which we've been doing for the last two sessions. As always, don't forget to like, don't forget to subscribe. You'll always get much more content that's relevant to you when you subscribe to the things that you are really wanting to watch. So what we've covered till now are the most important computing services. We've covered storage, compute services. Those are where most of the questions come from. The other ones that we're going to cover today, analytics and machine learning, database services, and networking services. In the next session, we'll cover these, and we'll go through a lot more questions, sample questions for technology. Let's start with database services. If you used a database, you must have typically, or most of us would have used RDBMS. So those databases you might have used are like Oracle, Postgres, SQL Server, MySQL. So those might have been most commonly used by most of you. And those are used as operational databases, like to store any operational system data. What RDS does, so first service we're going to look at is Amazon RDS, and like typically anybody who wants to get on the cloud first sets up data on S3 or sets up a server on EC2, and they also would need a database, so they would start dipping their toes with RDS. So typically lot of people do use RDS as their first database service. But what is the big advantage of using RDS over like doing it ourselves or doing an EC2 instance and then installing this? You could very well install Oracle software on your own server, which is the leftmost here. If you look at that, if you do it yourself, then you'll have to take care of the server, the complete server itself, getting the server, hardware related stuff, any OS patches on that. DB software, you have to install it. Any patches that come up every now and then, you'll have to keep installing it. You'll have to take care of backing up your data every day, every week, depending on the criticality of the data. You'll have to make sure the data is highly available by making redundant copies, or by ensuring that the data is backed up and it can be brought back online as soon as possible. Scaling, so how do you when the server is at capacity, how do you scale up? That's always a problem with operational data, and optimizing the app itself. So you'll have to work on all those things all by yourself. But when you do it using an EC2 instance, the middle part here, what happens is you EC2 instance at least is being taken care. So whatever Amazon does is it takes care of all the hardware part of it. So the power of the actual power lining, the HVAC system, making sure it's cooling, any rack and stack, server maintenance, OS installation, all those things can be taken care by Amazon AWS. If you use the EC2 instance and then you install Oracle or any other database on top of it. The part to the right, if you actually use RDS, what will happen is the part to the right where all the pieces, including from the power until scaling, high availability database backups, everything gets taken care by RDS. So the major thing to remember here is when you go for RDS, it's a managed database service. So it gets managed by Amazon. You don't have to find out what kind of server you need, what kind of we really need to understand what kind of RAM it needs and storage it needs. But you don't have to actually install it and serve it up from where you are. So it essentially gives you a easy way of setting it up, scaling, backing up. So all those things get easier when you go for the RDS service. The RDS service has 6 options: MariaDB, Amazon Aurora, which is their own equivalent, like Amazon's own equivalent of Oracle, or let me say Amazon's own equivalent of MariaDB, Oracle, PostgreSQL, MySQL. So Microsoft SQL Server could be an option, PostgreSQL could be an option, Oracle could be an option, and MySQL could be an option. So there are 6 options that Amazon RDS has. When you choose RDS, you can choose one of those 6 options. And Amazon Aurora is based on open source database software, and it has been made better or optimized by Amazon. So if you look at the bottom there, what kind of services do RDS provide? Like we can build read replicas, we can customize the performance, we can have automated backups, so we can set up the backup to be happen every once in a while. We can build an IAM integration, so we can provide access based on IAM. We can make it cost effective, we can make it highly available, and we have enhanced monitoring capacities. Obviously, this is not a technical exam. They're not going to ask you much more in detail than this. If you understand, there are 6 offerings, and these databases you can put in, but it's managed completely by Amazon, except for optimizing the app. Everything else can be managed by Amazon itself. By app for app optimization, we can choose how much storage we need and stuff like that, how much RAM we need, how much do we need a SSD, do we need a hard disk drive. So those kind of app optimizations, or designing the database itself such that it performs very well, all those kind of things are our responsibility still, but everything else we can rely on Amazon to take care of. So it's a managed database service. Let's dig a little bit deeper into Amazon Aurora. So Amazon Aurora, it's, as I said, they've taken the open source software like MySQL, and they've designed that so that it performs very well in the AWS environment. So we use it for high-end commercial databases, and what they suggest is that SQL 5.6 is the version they are supporting as of now, and it gives the 5 times the throughput of MySQL running on similar hardware. So if you set up your EC2 instance or set up your own server and run MySQL, the throughput would be 1/5 of what Amazon Aurora can provide. And because of that, DBAs save time. They can plan their backup storages much better, because the backups take much shorter. and they don't have to worry about like separate backups, because the backups happen into Amazon S3 bucket, and they happen in real time, and the backups don't actually like negatively impact the performance. So that's the biggest advantage of Amazon Aurora. They're automated backups, and they happen at a real time. They don't happen like at the end of the day. So in case Amazon Aurora is down for some reason, everything has been backed up to S3. So we can go back to S3 and look at the latest information as of few seconds or minutes ago. That concludes our portion with operational databases, RDBMSs. Let's move on to NoSQL database. Amazon DynamoDB is the most commonly used in the recent project I worked with. We worked on setting up machine learning prediction tool for a retail client, and we used Amazon DynamoDB for storing all the API calls, and for the API call history, um, any related store information on a daily basis. We stored it in the DynamoDB, and we used Snowflake for long-term data warehousing needs. So DynamoDB is a NoSQL database. It's a key value or document-oriented database. If you're new to databases and you're not understanding what a NoSQL database is, it does not have the strict rules of the SQL database. There are advantages and disadvantages because of that. The advantage is that you don't need a dedicated DBA coming in and defining the schema before you can start. And the schema is not very well defined, so you can add columns, you can like remove columns while you actually insert the data or update the data. So you don't have to predefine columns before you go ahead and do it. So you kind of remove the need for a lot of database administration. Uh, there are a few disadvantages, especially if you are if your team has extensive SQL knowledge. NoSQL databases do support SQL, but not they're not based on the SQL engine, so they don't typically don't support complete SQL. And DynamoDB has recently added SQL support, but it's not an extensive, and it does not cover all the SQL commands that you would normally use. So DynamoDB is another NoSQL or key value or document oriented database. So because it's a key value database, every value gets stored with an ID, and then to retrieve it, we typically use the ID and then retrieve it. We can't. It would be difficult to retrieve by, say, the 10th column or another column that you want to. So if you retrieve it by the ID, that would be really quick. NoSQL database would perform very well when you always know that you're going to retrieve it by ID. In my example that I gave, we store API call history for each day in DynamoDB before we back it up to Snowflake. So we use the API call GUID to store it as the ID, and when we need to retrieve it, we can go back and use the ID to retrieve it. As everything is a key value pair, it's you could store complex nested documents. So you can have a large JSON. So if you open up the Amazon DynamoDB, you'll find a huge JSON in it, and within it will have multiple nested variables within it. Another thing you need to understand is DynamoDB is a serverless database. That means you don't have to worry about the individual machines that run the DynamoDB. You don't have to set up the server. You just have to worry about setting up the DynamoDB itself, what features it would need, what kind of database size you need, those kind of things. You don't have to really worry about what underlying infrastructure it has. So this is a NoSQL, serverless database. So if you look at the picture below, like we could have a system where we have AWS vault within a VPC, and within which there is an elastic load balancer which hits multiple EC2 instances, and the elastic load balancer takes care of which EC2 instance to hit, and based on that, the EC2 instance could be connected to a DynamoDB, and it could read data from there and then serve the data back. So in the example that I gave, we built it using a Lambda function. We did not use EC2 instances, but if we build it for a retail client to get the information on a daily basis and store information from the retail client that's happening on a daily basis. So anybody using a mobile app or a computer, so they hit our web URL, and that gets into AWS through the elastic load balancer. I know there may be a DNS in between, a route 453 or something like that, but for simplicity, say they hit our elastic load balancer. The elastic load balancer hits multiple EC2 instances depending on the round robin method or other method that I mentioned in the last week. Based on that, it goes and hits the DynamoDB, like either to insert a record or to fetch some information from there, and then it provides the information back. So DynamoDB is three things to remember. It's a NoSQL database. It's completely serverless, and you can set it up in minutes without having to go through like any kind of information about the server and stuff like that. That should be enough for you to get through your exam for Amazon. Let's talk about Amazon Document DB. This is another NoSQL database, but if you're familiar with MongoDB, Amazon Document DB is very similar to MongoDB, and Amazon Document DB also has MongoDB compatibility. So you can actually choose that to use the MongoDB software itself. So what it does is it's a document database. It's fast, it's scalable, it's a serverless service as well. It's highly available, and it's fully managed. So it's you can use that for MongoDB purpose. Let's move on to Neptune. Neptune is a graph database. So graph database have been rising in popularity. Neo4j might be something you might have heard. So those are really popular, and graph databases are especially useful when you have like social media kind of websites where somebody is linked to multiple other people, and that multiple other people might be linked to multiple other people. So that kind of networking is well served using a graph database. So Amazon Neptune is a very good competitor for Neo4j. It's fast, it's reliable, it's fully managed. So you don't have to set up any of the servers and stuff like that. It's a high performance graph database, and it's optimized for storing billions of relationships. So as I said, if there are relationships between people, because it's a social media, you can store like billions of them, and the database is still optimized for querying at milliseconds. The next thing you need to understand is for Amazon Neptune, like you can completely build popular graph models, including property graph and W3C's RDF, and you can use their Amazon their respective query languages like Apache Tinkerpop, SparkQL, so that if a team already uses SparkQL, that was like one of my like my previous teams that I was working in, they were using SparkQL, and like I uh, I I was there until they were using SparkQL. When they moved to Amazon Neptune, they were able to use SparkQL without any learning curve. Let's move on to the next one. This is another important one as well, Amazon Elasticache. If you've heard of Redis, which is the most popular one, and the next most popular one is Memcache. So Amazon provides a service where you can actually set up a Redis database or a Memcache database. And the difference between like the Elasticache database is that this is an in-memory cache. So if you want to do some very high performance application, or if you want to get back data that is very frequently accessed, then those kind of things can be set up in high performance Redis or Memcache database using the Amazon Elasticache service. Biggest advantage is that it's all in memory. It's not stored in a hard drive or a SSD. Everything is stored in memory, so the retrieval times are going to be very low. It does not have to go and access your database, disk storage, or anything like that. It's compatible with most applications. People add a Redis or a Memcache data store in addition to your existing database. Say for example, you have a gaming application, and you want to keep the scores that are happening right now in your memory, so that when somebody's like playing a game, the scores keep updated on the screen. And if people are playing together, if 10 people are playing together, if 10 people have to see the 9 other people's scores, if everything is in a Redis in-memory data store on AWS, it can be quickly retrieved and shown up on the screen for the other 9 players to see each other's scores pretty quickly. So Elasticache, things you have to remember is in-memory database. It's again completely managed. You don't have to set up your instance and do it. Biggest advantage is that it has no disk I/O, it has no database access. Everything is done with the memory or RAM. And typically this database is done in addition to other databases. But some high performance applications, they might even do everything in Elasticache, but I haven't heard of an example. But I've heard that does happen in some examples. We'll move on to Amazon TimeStream. I'm not very familiar with this, but theoretically this stores a time series database. So whenever you want to store IoT data, for example, your watch has data about your heart rate every hour. So every hour, your watch takes your heart rate, stores it, and sends it over to the cloud. And we want to store that time series data, and that would consider that would be a very good candidate for Amazon TimeStream. I've worked with time series data earlier, but I've not used Amazon TimeStream. There are other options which are pretty good as well. So these kind of examples where you want to store time stream data, mainly understand that I gave an example where there's one watch which is collecting data every hour, which in itself would be like every hour there'll be like 24 readings. Within a year there'll be like 24 times 365 readings. And say if you're having 10,000 people in your system whose data is being added, just multiply that by 10,000. So that's a huge data set. But in most examples, we have per second or per minute readings, and we have like thousands of devices that we get data from. For instance, if you have a sensor that is measuring, say, your temperature in your server room, and you want to monitor that and store that as a time series data, that is a very good example where you'll have like millions of readings within months, and depending on number of sensors that you have, and like in the frequency with which it transmits the information, sometimes it could transmit as soon as it gets the reading, sometimes it could wait until like 4 hours, and every 4 hours it will probably transmit the information over to Amazon AWS. So those kind of places we can store the time series data, and Amazon TimeStream is an optimized for storing these kind of time series data. When you have data being a sequence of records over an interval, relational databases don't perform well, especially because of the size, and because like to analyze these and to retrieve these, because these are ordered in one particular way, so it'll be easy to analyze it when you use a Amazon TimeStream. The next one is partnership between Amazon RDS and Amazon VMware. So it's called Amazon RDS on VMware. So Amazon AWS and Amazon VMware are partnering up because VMware is the biggest provider with respect to virtual machines, and a lot of companies already have VMware related products. For instance, I was working with a bank. Every production UAT instance that they had were on VMware machines. So what VMware, if you're not aware of what VMware does, VMware builds virtual machines. So if you have 10 servers, you could actually build 20 virtual machines out of them, or like, I don't know, 50 virtual machines out of them. And each virtual machine would be walled off, and would to a user it look like it has everything that a server would have, including assigned memory, specified hard drive that only that server can access, and an OS that may be different from other VMs that are running in the same server. So this might have Linux, that other one might have like Red Hat Linux, the other one might have Windows. So you might have, and it might have different versions as well. And within that, you could install different software. So the bank I was working with, they had VMwares on all their like UAT and production machines, and though like sometimes they had to shut down the virtual machines, or they had to scale the virtual machine up. They were able to do that. They had to add more like RAM, or add more hard drive. They were able to do that and adjust all that using the VMware software. So the VMware software is very popularly used, especially when you have on-prem deployments. To use that and bring that into the cloud, Amazon and VMware have come together. Now we are able to use the VMware vSphere, which is the main software that we use to operate the virtual machines. We can use them in private data centers, or you can move them into AWS and still use the same VMware vSphere. And so your team, if they already have access to VMware, they're using it, and they're already using a few on-prem instances, they want to extend it to the other AWS instances, they can still do that. So everything can be done, and still use the VMware vSphere private data centers. And with that, they can still build up an RDS instance. So after using VMware, after setting up virtual machines, they can build RDS on top of it, and that makes the managed database much easier. Okay. Next is like if you've Amazon Cassandra, Apache Cassandra is another NoSQL database which is very, very popular. And like Amazon Key Spaces is the managed service that AWS provides for Apache Cassandra. What it does is it provides Cassandra workloads that you can run. managed by AWS. You can run the Cassandra workloads. You can use the SQL that Cassandra provides, Cassandra query language, which is very close to SQL, but they have some variations. Uh, as as I noted a little bit earlier, most NoSQL databases provide some kind of SQL support these days. It's very rare that a new NoSQL database may not, but they wouldn't provide all the SQL statements like that a normal Oracle or a MySQL server would provide. And if your team is already using Cassandra, they can use the same SQL, the SQL code. They can use the same Cassandra drivers, the same developer tools that they use today, and they can migrate over to Amazon Key Spaces. So it's a very easy transition to them. Let's look at Amazon Quantum Ledger database. This is a new database, probably within the last 2 years, and it's another fully managed ledger database. So whenever we have like something like a blockchain that we want to develop, we use something called a ledger database. The biggest difference between a normal database and a ledger database is that it's completely transparent and it's immutable. Immutable means you cannot change it. So if somebody makes a transaction, that cannot be overwritten by anybody else because that transaction has been written into the ledger database, like, and it has been stored in multiple places. So if somebody makes a change in one place, they would have to figure out the other places where this same information is and change that information to be able to actually verify that a transaction has been changed or it's a new transaction. For example, if there's a transfer of $10 from person A to person B, person C cannot go and say that the recipient is actually C and update the transaction because the ledger database is immutable. You cannot actually change it. And the way they make it immutable is that it's impossible for them to find out all the places this transaction is and change it so that the database knows that this actually has been changed. So it's transparent. So it's not something that like all the users users would be able to transparently know what's happening. It's immutable and it's cryptographically verifiable. So these are the most important things for any cryptocurrency, Bitcoin, blockchain related or Ethereum networks. So those, if you want to manage a blockchain, you want to store any kind of transaction ledgers. So then you use the quantum ledger database. Okay, the quantum ledger database tracks every application change and maintains a complete and verifiable history of changes over time. So this because of this history maintenance, it becomes impossible for somebody to go ahead and change something without other people noticing it. Okay, that is hugely important to understand with respect to like certain questions where they might ask you what database you would use, and they might give you a few options. So if you understand key spaces, the Elasticache, the Neptune, the Quantum Ledger, so these typically are asked as options, and you might use the information that you know. Like if you know that this is a Cassandra database, this is a Ledger database, you can use the information given in the question to either choose an option or eliminate an option. So that's how you will typically get this information used. Obviously, they're not expecting you to implement a QLDB or RDS for this exam. All you need to know is okay, RDS has RDBMS information, Quantum Ledger database has ledger information, and Neptune would be for this. So if you understand that, that's good enough for getting through this exam. The next most important service that AWS provides, it's not really a database, but it's a database migration service. I did not cover it in the migration part of it. I've just covered it here because it has a lot of information related to databases. Say you have a MySQL database on premise and you want to move it to an Amazon Aurora database target. So that's a migration. So anything that you want to do from on premises to AWS, or from AWS to AWS, or from AWS back as well. So I think for MySQL alone, they do provide a way where you can move from MySQL using Amazon AWS migration service back to on-premise as well. But typically, this service has been used, has been available for movement from on-premise to AWS and within one AWS database type to another database type. So that's how it's typically been used. But now they do have an option where you can move from AWS to on-premise as well. Okay. Redshift is the next database I'm covering here. It is typically covered, if you look at the color, right? So Amazon has it colored as a data analytics service. But the reason I wanted to cover it here is that it's much more easy to analyze the information and remember it with respect to databases, because Amazon Redshift is a data warehouse related database. It's a managed data warehouse. It has petabyte scale columnar database. So it's a columnar database and it has petabyte scale. So you can scale it up very efficiently to high levels. So if you have heard of like Teradata, anything with respect to Netezza, so those are columnar databases, and those are used for data warehouses. So I think if you're using that, this is, if you already know those services, this is the equivalent that Amazon provides. It's called Redshift. If you want any data from warehouse, we would want to say we would want to have an average of the sales that happens for the last 6 months. So everything that is stored as sale in the database, in the column where it has sales and a dollar amount, if you want to add all that and then average it, and then average it by say quarter, excuse me, if you want to average that by quarter, then that can be done using a columnar database much better than a relational database. It's 10 times faster, and pricing is pretty low at 1,000 per terabyte of information. So because it's stored as a column, because it's a columnar database, all the column related data gets stored together. So every sale dollar amount would be stored together, unlike in like MySQL or Postgres. Each row would be stored, and then the next row would be stored, and then the next row would be stored. So because all the column information is stored together, like aggregating it would be much easier. So just to reiterate the four major database offerings that you might have a lot of questions on. The other databases, mostly you will get a option that you'll have to choose or not choose. If you understand it theoretically, that's good enough. But the most important are the ones listed in the left. The Amazon DynamoDB. If you hear anything about document database, key value store, it's typically going to be the choice of Amazon DynamoDB. There are other NoSQL databases. So it like if it's a document database, it could be the MongoDB one. So it's most probably DynamoDB. Not going to always be the choice, but if it's NoSQL, especially if it's a document and key value store, it has to be DynamoDB. But if you see part of it, you'll have to think about it carefully. Anything with respect to SQL database engines would either be an EC2 instance with your own Oracle or would be an RDS instance. RDS is the managed database where you don't have to do all the legwork. Amazon Elasticache, if you hear of the word in-memory cache, then you know that it's talking about Elasticache. And it has two options, Memcached and Redis. Amazon Redshift is the option when you always hear the word data warehouse, or if you hear the word columnar database. So that those two things would give you the idea that it's going to be Amazon Redshift. That concludes our database services. Let's move on to networking services. For networking services, we need to understand the term called VPC, which is a virtual private cloud. I've talked about this a little bit earlier, but let's get a little bit more in detail. So let's look at the picture in the right. So on the left is the AWS cloud, and the customer network is at the right. So the customer has their own servers, people working on their computers, so those are called clients. So everybody is in the office network is within the customer network. If they have to connect with anything on the AWS, say they have a RDS instance, they have a couple of EC2 instances running, they have Lambda function that they have to call, that API they have to call. So those things, they need to go through something called a firewall. The firewall is where any kind of routing from the customer network outwards or inwards happens. So the firewall protects us from any malicious URLs, and it also kind of routes only to the right places. So within the customer network, there's a place where the customer firewall. So through a virtual through a VPN, it gets connected to both the Amazon cloud regions. So we have a solution that is spread across in AWS cloud across two regions, and each region has its own virtual private cloud. So virtual private cloud, I've said this earlier, this is kind of a walled area within AWS, within which your company's assets lie. So your EC2 instances would be inside the VPC. Your databases would be within the VPC. So anything that your company provisions, those will be within your VPC. So other users of AWS or anybody who gets into AWS will not be able to get into the virtual private cloud unless they get through the gateway. So unless they get through the virtual private network itself, which is like the virtual private network is separate for each region. So you cannot have one virtual private network that covers all the regions. So if you have a solution across two regions, then you have to separate them out. You'll have one VPC for region 1, the other VPC for region 2, as shown in the picture here. And for the customer to able to talk to this VPC region, so if they have to send a request to our EC2 instance, then the firewall, from the firewall, it will go through VPN tunnels. So the two lines that you see called IPsec VPN, those are like encrypted data passes through those VPN tunnels. And there's also VPG to VPC routing, where there's a virtual private cloud to virtual private cloud routing, where we say that this particular routing is where you set up communication between this network and this network. So if you want this virtual private network to be able to access this IP address and this IP address to be able to access this VPC network, so those setups are done in the routing table. So VPC to VPC routing has to happen, and it needs to know that this IP address can actually communicate to this virtual private cloud. So after we set all that up, and because the VPN like data is secured and it's encrypted, so even though the data between the customer network and the AWS cloud goes through the internet. It is actually encrypted and it goes through a VPN tunnel. That's typically what you need to understand for getting through the questions. Each region would have its own VPC network. You cannot have one VPC network across all regions. And there's also something called subnets. Subnets are within VPC networks. You can create multiple subnets. So within a region, say you have three availabilities, two availability zones or three availability zones. So each availability zone, you build a separate subnet for it. And like that subnet would have all the properties that that are going to be associated with that network for that availability zone. So you could set up multiple subnets within your VPC for each availability zone, or you can also set it up like even one availability zone can have multiple subnets. So like at least the subnet cannot go beyond availability zones, but you can have one for each availability zone, or you can have multiple for each availability zone. Okay, that kind of covers the VPC. Let's move on to CloudFront. CloudFront is a content delivery network. So if you want to provide data at a lightning fast speed to somebody who's sitting across the Pacific, so you are in like your server is in like Singapore, but you want customers who are accessing it from California to like quickly watch the video, browse the photos. So those kind of information can be provided in a content delivery network, CDN service. And Amazon's CDN service is called CloudFront. So you can use those. The next and like very important and always used service is a DNS service called Route 53. And the advantage of Amazon's Route 53 is that it's highly available, and you can use that to find the IP address of any domain name. So anytime you go on the internet, so you type in a website like google.com, gmail.com, amazon.com, like your internet service provider or your Wi-Fi router would route that information over, say google.com onto a DNS machine. A DNS machine is an internet connected service that provides the translation for google.com into an IP address such as like 192.0.2.11 or something like that. So that translation is provided by the DNS service, and Google has its own DNS service. Amazon Route 53 is used for AWS related DNS service. So you could have those domains available to the internet from anywhere, or if, for example, you have a URL saying my test tool -uat dot AWS east1.com. So that's where your application is hosted. So you want that to be under that URL, so then you can give them like if you give your users, like your testers, you can give them that URL instead of telling them an actual IP address. So that gets, so if you set that up, set that URL name to go to your application, either it could be a EC2 instance or a multiple EC2 instance separated by a load balancer. All those things you can set it up in Amazon Route 53. You can just tell that my application will be reached out to this URL, and then Amazon will figure out how to route it to one or multiple IP addresses, and that would get stored in Amazon Route 53. So Amazon will provide the domain naming service for your application. Next one is the transit gateway. So this is where you connect to Amazon's virtual private clouds and their on-premises networks using a single gateway. So if you're using hybrid cloud, that is some part of your system is in the on-premises and some of it is in AWS, you typically use a transit gateway. The transit gateway enables you to connect the virtual private cloud with the on-premises network. The Amazon private link. So these again, these, if you understand what each service is and how it differs from the other service, you'll be able to answer the questions by eliminating certain other things, or by by the clues in the question to tell you this is the service I would use, right? So next one is private link. It simplifies the security of data with cloud-based applications by eliminating the exposure of data to the public internet. So private link, what it does is it provides private connectivity between the VPCs. So if there are two VPCs, it gives private connectivity between them, and between VPCs and on-premises applications. And all this happens on the Amazon network. So for example, like you don't have to get to the public internet, because your on-premises is in North America, and your AWS cloud is in Europe. So using AWS private link, all this data travels through the Amazon network. That way it's completely secure and not exposed to the public internet. Okay, next one is the global accelerator. So if you have globally available clients and you want to provide them with very high speed internet when they access your like applications. Say for example, you have a website that can book people's hotels or flights. So you want to provide that to a global audience, not just to a local audience. Setting up servers everywhere would not be a practical possibility. So you would rather set up in two different regions, say one in the Western Hemisphere and one in the Eastern Hemisphere. Say one in Singapore or Asia Pacific and one in North America. So you set up two, which covers like most places in the world. But if somebody from Australia is hitting it up, or if somebody from Middle East is hitting it up, and they're using your service, they don't have to go through multiple. If you set up AWS Global Accelerator, it uses the AWS network to direct the internet traffic. So as soon as they hit your URL, the Amazon 53, the Route 53 helps it route into the Amazon network, and all the transfer of data happens through the global accelerator, and it happens much faster. Amazon AWS Direct Connect. This is where when you have on-premises data and you want to establish private connectivity to AWS, one was we saw about transit gateway. So that is a gateway where you can have the information being passed. And direct connect is a dedicated network connection. So this is where you have your data center co-located with AWS or AWS's partner. So you have your server co-located in the sense it has to be in the same building, so that you don't and you connect with AWS through that third party or through AWS itself. And when your server is directly on the same building or in the same location as AWS, so your connectivity between your corporate network and AWS can happen with a physically co-located server, because the network speed is now going to AWS network between your this thing, not through the public internet, so you can directly connect through it. So this is an alternative of transit gateway but it's needed in a very rare situation. So not everybody does this. You don't need as as fast a network as this unless you transfer a lot of data between you and AWS. So this is something that might be confused with transit gateway, but direct connect is where you actually physically co-locate, take your server and put it in a place where AWS data center is as well, so that you can connect it. Or this could be a third party where you connect it to the AWS network, where you put in your server from your corporate network, co-located along with another third party which can connect to AWS. So we saw a global accelerator. A little bit of context here. So if you look at the right picture, so if somebody is accessing your website through a computer, through the router, it goes to the local ISP, and then it gets the internet access, and from there on, the routing happens into the AWS network, and every information, like the all the information travel happens within the AWS network. And because of that, if you pay for a global accelerator network, you can actually make sure the customer gets it at a very quick speed, um, because AWS has like fast communication tunnels between regions, so their transmission between like Singapore and California might be much faster than going through the public. And if you look at this, they say that the performance can increase up to 60%. The next two services are not very familiar with me, but AWS App Mesh, like what you can do is any microservices that you're running, if you have App Mesh, it can standardize how your microservices communicate with each other, and it can give you end-to-end facility. And how do you ensure you have high availability for those applications? You can set all those up using the AWS App Mesh. So things to remember is, if you have a microservices that needs to communicate with each other, and most microservices do need to communicate with each other, you want to be able to set up that communication, set up the high availability for them, set up visibility as to which communicates with which, and what kind of pattern they use and produce. You can use AWS App Mesh. AWS Cloud Map is a resource discovery service. So what you can do is, you can define custom names for your application resources. So EC2 instances, you can set up custom names, and you can maintain the updated location of the dynamic changes in resources. So if the location changes, you can have those mapped out, uh, and you could at the end increase the availability of your application, so you can keep it highly available, um, and then that is a huge advantage of cloud map. I'm sorry, I'm not very familiar with that service, but I think theoretically, if you understand that, that's good enough to pass that exam. Elastic load balancing, this is something you get used quite a lot, um, but I didn't cover it earlier because it's not typically asked as a question, but when you use AWS, you will always use elastic load balancing. Elastic load balancing, we spoke about it in the last session. It distributes incoming application traffic across multiple targets. Say, for example, you have multiple EC2 instances, two in region 1, availability zone 1, and one in region 1, availability zone 2. So you have 3 in one region, but they are across availability zones, and you want to load distribute whatever is coming in. So you can set up such that the elastic load balancer takes care of that, and it routes the traffic according to the rules you set up. And the typical rule we set up is round robin. That is it hits the first one, then the second one, then the third one, then the third, then the first again, then the second and the third. It keeps going on again and again. Application load balancer um, is used for HTTP traffic and for HTTPS traffic, and it provides like not only for EC2 instances, but say you have a microservices, you have containers, um, and you could have multiple containers. So let's get back here. The important thing to understand about Elastic Load Balancing, I don't know if they're going to ask any questions about this, but it's good to know what this is. Like until now, whatever you understand is good enough for passing the exams, I think. But this piece where it can dynamically add more, like for example, if you have a way where you want to auto scale your EC2 instances, so when you have an auto scaler enabled, in the EC2 instances, when the traffic level is at a certain limit, then the Elastic Load Balancer will call in the automatic load balancer, and the load balancer, the Elastic Load Balancer will call the autoscaler, and the autoscaler will add more EC2 instances. And the new EC2 instance also needs to be load balanced by the Elastic Load Balancer, and that will be taken care by the Elastic Load Balancer and by the autoscaler. So as the autoscaler scales up or scales down, it adds more information to Elastic Load Balancer so that it can autoscale, it can load balance that additional EC2 instance as well. The same with containers. So if a container is at capacity and then it gets another container gets spun up, the Elastic Load Balancer would know that it has to balance the additional traffic as well. Okay, the next one we'll cover is the AWS Client VPN. The Client VPN is where you associate the subnets of the Client VPN endpoint, and then you enable the user to access resources. So VPN is a virtual private network. So a virtual private network is a network of devices or services, servers, databases that only people within the VPN can access, and anybody from outside, if they have to access it, there'll be rules to ingress and exit the VPN. And people within VPN could have like certain rules as to how they access the internet as well. So the how anything from the outside world comes into the VPN, or from the inside world is being accessed to the outside world. So you can have rules for both that. Say for example, your machine is connected to a VPN. You may not, certain websites may be blocked. Certain websites may be restricted for certain uses. So all those things can happen within a VPN network. And AWS Client VPN provides the service that needs to enable you to set up that client VPN. The last thing we'll cover today is analytics and machine learning services. Amazon Athena is a like whenever you have data on S3, say for example you have a lot of comma separated files that come in. If you want to quickly check what is the highest like value you have in the third column, then you probably have to take the S3 the CSV files and then download them, merge them together into an Excel, and then either sort them or filter them and find out which is the largest value in the third column. But what you can do is you can have Amazon Athena, which is a serverless service, so you don't have to really install anything. You can point it to this S3 bucket and look at all the files under it, and then you can define the schema or make Athena understand, like interpret by itself what the schema is. That is, if it has column names at the top, it'll take it up, and then use those as a column names for the tables, and then we can actually query those tables based on the schema that either you define or like Athena understands based on looking at the files. So you can define the schema and then start querying it. So as simple as that. So Amazon Athena is for any data in S3 that you want to interactively query. You don't have to set up anything. Just have your data on S3, and then you can go into Athena and say, okay, I want to point to this bucket, define the schema, and then query it. So as simple as that. Next one is, you've heard of Hadoop, HDFS clusters. So Amazon provides Hadoop related storage. S3 has kind of overtaken a lot of Hadoop assets. So a lot of people who had HDFS earlier are just storing it on Amazon S3 buckets these days, and getting all the functionality that they need from there. Um, but if you want your Hadoop framework to be existent, because you have a lot of HBase tools, Spark tools, Flink tools that you're already using, and you want to keep using that, then you can bring your Hadoop ecosystem onto Amazon EMR, or you can set up a new Hadoop ecosystem on Amazon EMR. So you scaling it, providing data in huge chunks, all those things is a huge advantage of Hadoop. And just remember that you can do everything that you already did. Like Apache Spark can be installed. You can use HBase, you can use Presto, you can use like Zookeeper. You can use all those things that you already did with Amazon EMR. If you had those tools earlier in a Hadoop network, you can use all those things. There's also something called EMR notebooks, which is based on the popular Jupyter notebook that we use for data science. And it provides something similar to that, some kind of similar experience. What those notebooks are for are ad hoc querying, exploratory analysis, and you can do the same thing using EMR notebooks. AWS Glue. I'm basically I've used Glue a lot over the last couple of years, and Glue is an ETL service, and it's completely managed. So it's ETL is where you extract, transform, and load, and the tools that do the ETL, including data stage or Informatica, provide ways where you do less coding and a lot more drag and drop configuration, and there may be a little bit of coding involved as well. So that's the advantage of ETL. And AWS Glue does this. And AWS Glue, you can if your data is already on the AWS network, you have it on Aurora DB, you have it on DynamoDB, you have it on Oracle on an RDS instance, you have it on S3 bucket. So all those things you can easily use Glue to point, extract the data, transform it, and store it, say, in a Redshift instance where you want to use it for analytics, or you want to use it on another S3 bucket. You want to put it back in S3 bucket, so you can do all that using AWS Glue. So AWS Glue has a few things like data catalog, which is where all your information about all your data. So if you have 5 data sources, each data source has its own schema, like it has its own table definition. So all those things get stored in the Glue data catalog. The other things about AWS Glue is the AWS Glue Elastic Views. With Elastic Views, what you can do is you can build materialized views. Materialized views are where in real time, any changes that happen, okay, a view is where like you have 3 different databases or 5 different tables. You want to join them in a certain way, and then look at that information. Then you can build a view on top of those 5 tables, and then that view will give you access to that joined information from those 5 tables on a view. A materialized view is where this information materially moves, or I mean moves, physically moves from the source into this materialized view, so that this calculation of joining these 5 tables do not happen when somebody queries it, but it's always there and you can look it up whenever you want. So that's the materialized view, and AWS Glue Elastic Views helps you do that materialized views. And it's like if you look at that picture there, so you can build a materialized view based on Aurora DB, RDS, Amazon DynamoDB, and then you can all those data get replicated continuously. So at a real-time basis, any changes that happen, say in the third table in RDS, that gets updated in the materialized view on AWS Glue Elastic Views, and then you can use that on your Redshift, your DynamoDB again, or whatever you want. Amazon Glue Data Brew, that's the last thing we'll cover in this slide, is a visual data preparation tool that makes it easy for data analysts and data scientists. So it's a data preparation tool. It's something like if you've already used Alteryx or something like that. So AWS Data Brew could be an alternative for that. So you can make sure that your data is prepared so that you can use it for any kind of visualization you need, or analytics or machine learning. So all those things you can quickly do those transformations. It's kind of like a mini ETL per se, but it's used specifically for data preparation. So if you want to remove all null values, or if you want to remove the non acceptable values which you don't really want to work with, so not applicable ones, you want to remove the nulls, if you want to clean the data, so all those things you can do using do data. I call it mini ETL, even though it really isn't, but that's what I remember it as. The next thing is Amazon Kinesis, and there are like 4 different Kinesis services that we're going to look at. When you have streaming data, that is data that keeps happening on real time, and you keep storing it in real time. For example, like any credit card transaction that happens needs to get stored in a place, but like before that the transaction goes through, we get the information, we process the information, we check it for fraud, and then we store the information. So that kind of information we did for one of the banks when I worked on it. We used Amazon Kinesis equivalent. We didn't use Amazon Kinesis, but it's real-time streaming data. We did consider Amazon Kinesis, but we are not as much into the AWS environment yet, given that it's a bank. But for an exam perspective, what we need to understand is that any kind of streaming real-time data, a very good suitable candidate would be Amazon Kinesis. It's cost effective, you can do it at scale, and you can choose the tools that you really need to use. For example, if you're doing video related like live streaming, or if you want to make sure the video gets processed before it live streams, so those kind of things you would use Amazon Kinesis video streams. If you want to use data streams, like the example I just said, credit card transactions, we have multiple transactions happening at the same time, use Amazon Kinesis for data streams. Amazon Kinesis Data Firehouse, like this is if you want to use it for data analytics, like if you want to load the streaming data into your S3 bucket or Redshift, then because the data has to get combined together. Say for example, you want every minute you want to have the total transaction amount, but you're having like 10,000 transactions a minute, and you want to average and sum the transactions every minute, and you want to store that information. So you have a lot of data processing that's happening while the data is streaming real time. So those examples use the Kinesis data firehouse. And data analytics is to use the last one is Amazon Kinesis data analytics is the if you want to analyze streaming data and gain insights out of it, so you that is when you actually want to use Amazon Kinesis for data analytics. Amazon Cloud Search is a managed search provider. So when you set up search on your website or on your app, so if you want to search, say for example, you go to Amazon.com and you search, there are multiple categories you can filter based on, and you can set up like buttons where you click and choose certain categories and not choose certain categories. You could probably have a range of prices, a range of sizes that you can choose from. So you can have those kind of setups. So when you set up a search, you need to make sure that you're able to have auto completion. You're able to highlight the words that people are searching up when they show up the results. So a lot of those things need to happen, and those things can be easily implemented because those are common across most of the other search providers. So you can use cloud search for that. So that will give you categorizations. It will give you like filtering based on ranges. It will give you the highlighting. It will give you the other search features that you need typically. We already saw Amazon Athena. So S3 bucket, if you want to query quickly, that's what Amazon Athena does. So I'll skip that up. Amazon Open Search Service, which is like some people might still call it Amazon Elasticsearch Search Service. So when you want to set up, you want to have Elasticsearch, but you want to scale it to search, analyze, and visual data in real time. So that at that time you rather use the Open Search Service. With the Elasticsearch Service, what you do is you get a easy to use API, and you can use like log analytics, full text search, use application monitoring, clickstream analytics. Like if you hear the words Kibana or Logstash, then you can choose the Open Search Service as the option for that. The next one is Amazon QuickSight. For QuickSight, if you are using anything related to BI, say for example you're using Tableau, Microsoft BI. So these are tools where you can quickly visualize what you're doing. So it's a business intelligence tool where you can put in a graph which shows your quarterly revenue by store, or you can show up your API analytics, and you can put that in the BI and show how many of your requests have timed out, how many of the requests have a 401 or 403 errors. So you can visualize that quickly in graphs. So those kind of things can be done using Amazon QuickSight, which is an alternative for like Tableau or Power BI or any Cognos, those kind of things. Amazon Lake Formation. This is if you want to set up a secure data lake. A data lake is a place where you bring in the data as it is present in the source system. You don't really transform it, and you can have a lot more data than you need. So you store everything, and then you decide if you want to use it later. So that is a data lake. So to create data lake, AWS Lake Formation helps you set up a secure data lake in days. So it's centralized. So you have one data lake, and it's a secured repository that stores all your data. And you can also store it in your original form and prepared for analysis form. So you can store it in both the forms in the lake formation itself. So the next one is AWS Data Pipeline. This, if you want to process data and move data between AWS services, you want to store from EC2 instance, you want to move to a different compute instance. If you want to store data from S3 bucket onto a move it onto a RDS instance. So all those things you use data pipeline. You can create complex data processing information for that. and you can still provide highly available fault tolerant solution with it. The next one is manage streaming data for Kafka. So this Kafka is the tool I was using for streaming the data earlier. So, but Amazon also provides a Kafka managed service as well. So here is any kind of streaming data. Kafka is the best platform and it's open source. So Amazon MSK gives you the managed streaming for the Kafka. You don't have to set up your Kafka clusters. You don't have to scale them. If you can go into Amazon managed streaming, and then you can set that up. Amazon AWS Data Exchange is kind of a place where it's kind of a marketplace for other people's data. Say for example, Dun and Bradstreet has a lot of information that the banks that I work with buy from. So if they want the data, or say for instance, like a provider has all the address information in North America, and they want to be able to sell to other retail customers so that they can use it for marketing, for standardizing the addresses. So those can be published in the data exchange. So you publish it there, and then people can buy it from you. So Dun and Bradstreet is going to publish their information, and they have like 330 million global business records published there, and then like whoever wants to subscribe to that information can subscribe to the information. And as the data changes, Dun & Bradstreet will change the information in the database, and we'll still have because we are still subscribed to the data, we'll still have access to the updated data from Dun & Bradstreet. So Amazon FinSpace is data analytics and management specifically for the financial services industry. So FinSpace is suited for any kind of analytics that you do, like with stock exchanges, security prices. You can add all that information. You can build risk management services, portfolio services, actuarial services. So these are typically analytics that FinSpaces use. The only thing I don't see there is regulatory, but like every other thing that normally financial companies use, AWS is providing. We saw about AWS data migration service, but a quick note here. You can do homogeneous migration such as Oracle to Oracle, and you can also do heterogeneous migration. That is, you want to move from Oracle to Microsoft SQL Server, Oracle to Amazon Aurora, or Microsoft SQL Server to Aurora. You can do that as well. You can also set up the database migration service so that you can continuously replicate data. So if you want to like replicate data with low latency, that is, you want to make a copy of it every second or minute, you can do that as well. You can also consolidate multiple databases into Amazon Redshift. So you want to move multiple database data into the Amazon Redshift data warehouse. So you can use AWS data migration service for that as well. So DynamoDB is another thing we saw. Some questions that could come related to that, a little bit more depth of knowledge that you need to know is eventual consistency versus strong consistency. What is the eventual consistency is that like when if you're not too worried about your data being perfect, that is everybody getting the most updated data, then you can choose the eventual. These are two options within DynamoDB that you can choose for your reads. If you choose eventually consistent reads, what will happen is you will have very fast reads, so people can read it fast. But say there's an update that has happened, that is in write operation, somebody has updated that address. You have stores and store addresses in a table, and somebody has updated the store address like at 2:13 p.m. and if somebody is reading it at 2:13 15 seconds, if you're fine with people having the old address for a few seconds or a few minutes, then you would use eventually consistent reads. That is, the data may not be perfect it may be stale data for certain seconds, certain minutes. I mean, I wouldn't say certain minutes, probably a minute or so. But you might have stale data when you read it. So you might have data that is changed, but you're actually reading the old data. But if you're okay with that, if that's not a concern for you, you want people to be able to read much quicker, you use the option of eventually consistent read. But if you want the other option, you choose strongly consistent reads. When you choose strongly consistent reads, you only read the most up-to-date data. Anything that somebody is able to read would be something that has been updated. You would never get a information that is incorrect or stale. So what will happen is um, you may have to wait for the update to process and get into every replica of that. So in DynamoDB, like the data is stored at least in two replicas. So it's stored in one place and in another availability region in another place. So if somebody updates the store's address, the DynamoDB has to hold both the records for other people to read it, update the first location, update the second location, then remove the lock so that other people can start reading it, and then so the people who wanted to read the same record, same address, would be waiting for reading this record, and they'll get it only after the update has been done. So they will get it only they'll never get stale data out of it. So those are two options within DynamoDB they could ask for. When you set up a DynamoDB, set up reads for it, you could set up either eventual consistency or strongly consistent. We did look at Amazon Neptune. It's a graph database. The biggest advantage is you don't have to do any hardware provisioning, software patching. You don't have to do backups configuration. You don't have to do any other configuration for the servers. So any kind of SparkQL, W3C, Tinkerpop, Gremlin, OpenCipher. So for any graph APIs, Amazon Neptune is good for people to use it. Another note towards our end of our session today is about serverless. So a lot of things because Amazon is moving a lot towards serverless. Serverless is very important in their strategy. In the reinvent that happened last week, they had a lot of information about how their services are moving to serverless. So this has been a huge strategy change for them, and it's because of competitors like Google Cloud being well ahead in serverless. Amazon is also trying to not lose their market share because being late on serverless. They're already the biggest market. They have the biggest market share out there, much bigger than the next three combined. So they're trying to play their card very well here. So serverless enables to build applications without thinking about servers. So here, this gives you a list of all the serverless services that we have. In compute, when you talk about serverless, it's going to be Lambda. When it comes to containers, it's going to be Fargate. When it comes to application integration, that is talking between applications, it could be SQS, SNS, Event Bridge, Step Functions, or AppSync. Storage, S3 is the serverless option that they have. For database, it could be DynamoDB, Amazon RDS Proxy, Amazon Aurora Serverless. So you have these is the serverless options. Don't forget to subscribe, like. The more you like these videos, more YouTube is going to provide you more AWS related content. So if you're interested in a lot of AWS related content, hit the like button below. Thank you so much.